Welcome to the second part of our conversation today with Charlie. Charlie, I'd like to hear from you of a few design stories about the Petronas Tower in Kuala Lumpur. Like, what were the challenges or learnings? How was the technology transfer to Malaysia managed at a time when there were no steel industry, no high strength concrete, and no exterior wall industries in Malaysia? And also, how much of the conceptualization of these towers were derived from the Breitler Tower of Chicago?
Right. So, first of all, in Chicago, you have dolomitic limestone,
Yes.
which can produce 20,000 psi concrete. And we did test caissons with high strength concrete because we were afraid that the heat of hydration might start the concrete boiling.
Yes.
It didn't.
Okay.
We actually built some large diameter, 4 feet, 5 feet, 6 feet. And then we also experimented with the high strength concrete. And we had Clyde Baker, geotechnical engineer, one of the best in the world. We used him on both Petronas and Taipei 101 along with local engineers.
Yes.
And what the breakthrough was that Cesar Pelli and John Picard, the two lead architects, are brilliant architects who ask and listen. And I said, look, you're going to use the Islamic star as the footprint. You're going to make this a Muslim building. And I think we're going to win because nobody else did that. And why don't we use 16 columns? And they'll be at the bottom of the building, they'll be 7 feet in diameter. And then the core will be 70 feet by 70 feet. And give me 2 webs, one in each direction, right down the middle, and 4 flanges. Of course, the core is nothing more than a series of webs
Yes.
and flanges.
Yes.
I said, if you do that, this will be the least expensive, world's tallest building ever constructed. And it was.
Yes.
They listened. Now, the challenges. The first challenge was the Prime Minister and Petronas, the national oil company, required that if we used any material that was not native, indigenous to Malaysia, we had to figure out how to get it.
Yeah.
And we're pretty good at that. So my colleague, Udom Hungsbrook, brilliant Thai engineer, graduated from the University of Mapua in the Philippines, which apparently is the MIT of the Philippines. He went to Trade Abed. He went to Luxembourg. And he said, look, we're going to do 88 stories twice. And our beams are going to be no heavier than W18 by 35s. Will you set up a fabrication plant in Malaysia? And we'll guarantee you that you get the job. And they did. And I believe that the offspring of that project, that plant, is now the largest steel plant in Dubai.
Yes.
Same group.
Great.
The second thing we did is we went down and we talked to the Australian high strength concrete guys. And we said, okay, we need 18,000 psi concrete. Are you willing to be hired by Lara McGovern, the construction manager,
Yes.
to set up batch plants on the site to make 18,000 psi concrete? And they did. And then Cesar Pelli, with a little help from us,
Yes.
they went to see Permis de Lisa, the largest exterior wall manufacturer. And they said, if you set up a plant in Malaysia, you'll get the stainless steel facade on the world's tallest building. And they did it.
Great.
Right?
Yeah.
How do we do that? We do that with persuasion. We have enough confidence that what we're talking about doing, we are going to do.
Yes.
And no, it's always steps.
Yeah.
It doesn't happen overnight.
Yes.
But the biggest challenge was the foundation. I got there in November of 1991,
Okay.
first meeting. And I said, okay, why are these two buildings situated here? Well, that's because Collages Vale, a planning firm from Los Angeles, laid them out and put them there. I said, well, do you have any borings? And they said, no. So we said, well, sorry, we can't develop the foundation scheme unless you have borings. So
Yeah.
Udom went over and he mobilized all the drill rigs in Southeast Asia. And we basically peppered the site with borings. We went right down between the two buildings, 600 feet, nothing, no rock. Went to the outside of the two towers, 40 feet to rock. We were sitting in a caustic limestone valley. And caustic limestone has slump zones, cavities.
Yeah.
And we said, okay, let's do the borings. We now have the borings. So I go back the next time and they go, look what I found. I found a geotechnical report in a drawer in our office. And it says, move the buildings. It was done before we even got involved. So that was an easy decision. Then we jet grouted. We basically used 70 barrette piles, 1 meter by 2 meters or 3 meters.
Okay.
High strength concrete. But we jet grouted the entire site with 25-foot on center holes. And I think we pumped 5,000 cubic meters of grout into the bottom, because otherwise we were going to have the leaning tower of Kuala Lumpur.
Yes, yes.
And the biggest scare of the project was when one of the managers on one of the towers, Valera McGovern, was kind of a wise ass. And we said, the cores were 70 by 70. We wanted to put the express elevators outside the core in drywall. And they said, no, we want them part of the core. That's when I said, I got a core here, and I got a core that's eccentric.
Yes.
It's eccentric by significant, like 10-foot eccentricity. And when you hit the 50th floor, the sky lobby floor, probably 41, you need to take daily surveys. And if your jump form is going off, you got to rack it back. One contractor did, and one didn't, because Larry McGovern didn't make him do it. So I get the call that the building is tilting. And I go, oh. So we send Udom over. He loved it because his family was in Thailand, right over the border. So every time he went home, he saw his family. First class.
Yeah. Yeah.
So we caught it. The building actually makes it's an S curve.
Okay.
But we had to do some work on the elevator guide rails, and the cover on the rebar was too much in some places and too little in others. And but here's the scary thing. I get in the taxi cab and I say, take me down to Kuala Lumpur City Center. Oh, he said, you're involved in that? Is it still tilting? Cab driver. No, it stopped. But the really great meeting was when we made the final presentation to Dr. Mahathir, the Prime Minister.
Yes.
And we had 15 models. One was short, and the 15th was the world's tallest building, right?
Yeah.
And Caesar's got them all down behind a table with a white tablecloth, and the Prime Minister can't see him. And Caesar goes, and the Prime Minister smiles, and then he goes, And finally, and the prime minister is busting. He's busting with excitement. He says, "Would that be the world's tallest building, Caesar?" And Caesar very quietly, demurely says, "Yes, sir." And the prime minister says, "Can we do it?" And Caesar turns around and says, "Charlie, can we do it?" And I said, "Absolutely." I had run all the numbers on
Yeah.
Bigler and Beitler,
Yes.
which was
Yes.
smaller in diameter and 500 feet taller.
Yes. Yes.
You don't, if you're a smart engineer, you don't say, "I got to go back and run some numbers." You don't do that. You'll never be invited back.
Yes. Yes.
So it was an exciting project. We made a lot of
Yes.
money on it. We got paid a lot of fees. And obviously, it put us on the map.
Yes. Surely. Charlie, would you like to share any stories about the next tallest building project of the world that you worked on, the 101 Taipei, and the use of the tune mass damper for this project?
Fortunately, I did not like flying through the Japanese airport. I like Taiwan, and it was more direct, more direct than going up to Japan.
Yes. Yes.
And I met Mama Lin, Chinese woman, whose billionaire husband had been selling condos at $1 billion a year, and he died.
Yeah.
And I knew Turner International, and I had done a lecture series in Taiwan
Okay.
for the Taiwanese Society of Architects, Engineers, and I knew Dr. Shu from Evergreen. He was a co-speaker with me, and when we were in, I was asked to go and make a presentation to Dr. Li, the president of China, who's a Cornell agricultural PhD.
Okay.
And I was brought there to explain to him that we could do the world's tallest building in Taipei.
Yes. Yes.
And that's how we got that one.
Yeah.
And
So
it took from 98 to 2002 before it really happened. So I was not involved in that as much. The concept was originally mine, and it was all concrete filled tubes.
okay.
And so that gave us mass. We didn't want complete mass because Kuala Lumpur doesn't have earthquakes really, but Taipei has typhoons
Yes.
and
Yes.
big earthquakes.
Yes.
So that's why we put the TMD in. It's an 800-ton ball. I have never seen it. But unlike the United States, they're very proud of the fact that it's got a big TMD.
Yes.
They have a little mascot, I think. So, but in the United States, the lawyers are so afraid that if they turn on the TMD and for some reason it's not working, and then a storm hits and they knew it wasn't working, they're going to get sued.
Yes.
So they never test them.
Yeah.
That's the problem in the United States. Everybody's so risk averse.
Yes. Yes. Yes.
So anyway, the TT is now doing the one in Jeddah,
Yes.
a kilometer tall, 3,300 feet.
Yes.
And apparently the upper 40 floors are not occupied. They never will be occupied. They just wanted to go a kilometer.
After transitioning out from Thornton Tomasetti, you still continued to work to bring forward to the world your disruptive and innovative engineering and reunited with one of your fellow engineers to develop a radically new concept of building construction, which promised to put costs in half, complete faster, and become a more safe work site for workers. Could you share with us what this revolutionary approach is and how did it develop over the years?
So in 1971, I met David Termolen. He had invented a system that was used on 4 buildings in the Bay Area, all
Yes.
12-story office buildings. They're still there. If you go on my website, TGE Top Down, there's pictures
Yes.
of them. They had a little superficial damage in Loma Prieta,
Okay.
but nothing major. Then he had one in Los Angeles that they tore down because they blew it up. They made a big project.
Yes.
Then he came to New York City to do the Russian mission to the UN just before the Arab oil embargo.
Yes.
And I said to him, you want some help on opening Saudi, Iran, and Russia? And he said, yeah, will you join? I'll pay you, my company will pay you top dollar. So I started jet setting on TWA and Pan Am, so you can tell when it was.
Yeah.
And we were designing 15 buildings at the World's Fair. I'm sorry, at the Olympics in Moscow that were going to happen in 1980.
Yes.
Russians invaded Afghanistan. Jimmy Carter pulled the US out of the Olympics.
Yes.
And that's the year I bought, Tomasetti and I bought LCA.
Yes.
So from then, from 78 to 2005, I didn't really think about the system.
Yes.
And then I decided I was going to patent it, repatent it, and start a company and find some people that would invest in it. So we did a whole bunch of studies. And then the big day happened when Intel decided they wanted to build a building in half the time at half the cost in Bangalore, India. And we did it. 625,000 square feet. It's on the TGE top-down website.
Yes.
We slip form the cores, which is faster than jump forming. We put the floors together on the ground. We put the exterior wall on the ground. We put all the furnishings if they come on time. And we built the building in 16 months and 12 months versus 38 months and 36 months.
Yeah.
And Jeff Grillo, head of worldwide construction for Intel, left his job of 22 years, and he's the G. And Dan Esplaza, a general contractor from Seattle, he's the E. And we've got 3 or 4 projects starting in the United States.
Great, great.
The hotels and residential buildings and modular. We can slide modules right on the floor, on the ground. They don't have to be stacked. So every box is the same.
Yes.
So anyway, you know, I work 60 hours a week because I love it. It's not work. When I worked in the field, when I was in my teens, I was bored. The minute I started working as a structural engineer, if I looked at my watch and I saw it was 5:30 time to catch the train to go home, I was kind of disappointed.
Yeah, you're not loving your job.
Yeah. The other thing that I advise is never travel on weekends when you're married and you have children. Be home on weekends. There's no reason why, if you have a client, the only time I ever spent 2 weekends away were in Moscow.
Yes, yes.
And that was because we were getting paid. So, but I never, you know, I flew to Kuala Lumpur for a one-day meeting, 24 hours each way.
Yes, yes, yes.
But they were paying us first class. So it's been fun. I mean, very satisfying. I'd say most of the people that I've hired really like me.
Yes.
But you're not a good boss if they like you because you were weak.
Yeah, definitely.
They got to like you because you were tough. And the biggest fear that I ever had, what drove me to work really hard, was fear of having to lay off my staff.
Yes, yes.
So I worked my ass off to never have to lay off my key staff, and we never did. And usually what happens when your committee decides that they're going to terminate somebody, the person comes in and says, my wife's pregnant.
Yeah, yeah.
I just bought a house.
Yes.
And you go, oh God, I can't do it today.
Yes, yes.
It's not fun.
Yeah, yeah. And also, could you let us know from all the benefits and cost reduction that this method is offering, why hasn't it yet been adopted in many projects here in the US so far?
Well, it is now. Let me tell you what's wrong.
Yeah.
Number one, David Tremolin did the 7 buildings in the United States because he was the developer, he was the designer and the builder.
Okay.
American general contractors don't want to save money and don't want to save time because it takes money out of their pocket. So the big boys don't want to do it. Okay. They also don't have any balls and they don't have any brains. You ask them to do something they haven't done before, they say, if I haven't done it, I can't do it. What the hell kind of an attitude is that? If Kennedy said we're going to the moon by 1970, and everybody in the aerospace industry said, well, we've never been to the moon, so we can't do that. The question is, pay us enough money and we'll do it. So basically, the general contractors torpedo us. So we went to India, and Intel was paying 3,000 people rent in rented space for 3,000 Indian software engineers.
Okay.
Costing them $860,000 a month. Conventional cast-in-place concrete was going to take 38 months. We did the first one in 16 months. Take the difference between 38 and 16 and multiply 870.
Yes.
It was a pretty easy decision.
Yes.
And they trusted me. And Jeff Grillo and his partner, Mark Schaefer, said to the CEO,
yes,
if it doesn't work, BK, fire us.
Yeah.
And they didn't. The top management of Intel doesn't appreciate anything that anybody does. They're all selfish software engineers, Silicon Valley types.
Yeah.
So they gave us the first building, and it was 134 million instead of 250.
Yeah.
Big. And they gave us the second building, and it was 12 months instead of 16 months, and it was 110 million.
Yeah.
So $244 million versus $500 million.
Yeah. Yes. Yes. That's
And
a lot of savings.
Jeff Grillo and I became friends. And he said, I want to join you. I'm retiring. I'm quitting. I'm leaving Intel. What can you do for me? And in the same way that I did with Richard Tomasetti, I said, let's just you, me, and Dan, let's 1/3, 1/3, 1/3, and let's see if we can make this work.
Yeah.
So we've got one starting in Denver. We've got two starting in Seattle. We're going to base isolate them because
Right.
we only have cores. We don't have any columns. So each core just gets 4 base isolators at the 4 corners. We're going to use pendulum, friction pendulum.
Oh, okay. Okay.
Yeah, Victor Zayas up on Treasure Island in the Bay. He's an old friend of mine. He worked for me for a year in 1970.
Okay.
Out of Cooper Union. And he said, okay, Charlie, I've been here a year. I'm going to Berkeley to get my PhD. I said, and we're still friends.
Great.
We also put computer in structures. Ashraf Habibullah.
Yes.
We put him on the map. We put him on the map when we basically said, look, you give us a break on SAP 2000. We will tell the world that SAP 2000 made this project possible. That's the kind of wheeling and dealing you have to do. But you got to deliver. Otherwise, they say you're full of shit.
Yeah.
But now we've got Mortensen, we've got Hensel Phelps, we've got DPR, three major contractors
Yes.
who all want to build the one in Denver. And once we get a major U.S. contractor to show the U.S. market,
yes,
you'll make money. I told Turner, I told Gilbane, I told all the big contractors, add double your profit.
yes.
Instead of 2%, make it 8%.
Yes.
If we're going to save this kind of money, but you have to train your staff.
Yes.
You need to send them to our school. You need to send them to charrettes, to boot camps, you need to, and by the way, we have a vertical supply chain. We have steel fabricator, steel erector, slip forming of the core, jacking of the floors, exterior wall, and floor decking. They're all part of our supply chain. And if a client comes to us and shows us a 20-story building, we'll give them a guaranteed max in 4 weeks. Guaranteed maximum price in 4 weeks. It'll be at least 20% less than a concrete flat plate.
Yes.
Okay.
Yeah.
And it's backed up by real bids from real contractors.
Charlie, one more from the many accomplishments that you have gained so far has been the founding of the ACE mentorship program. Could you share with us your vision for this program and why did you feel there was a need for such a program?
When I was 16, 17, my father was chief inspector of the New York City building department.
Okay.
And he used to get all the kids, all the high school dropouts in my neighborhood jobs in the unions.
Okay.
And I thought that was pretty cool. So then I got to a certain point where in 1990, when the Soviet Union took down the wall in Berlin,
Okay.
everybody was basically predicting that there was going to be a slowdown in engineering education. And
Okay.
my alma mater basically was pushing the panic button that they might close the engineering school, which would have been stupid as hell.
Yes. Yes.
So I went up and I met with the board of trustees and the faculty. And I said, look, I've got an idea. You're a Catholic school, and you forgot about the fact that all the Catholic high schools in New York City used to send white boys to Manhattan College. Well, they don't have any white boys anymore. They have people of color. They have Hispanic, they have Asian, they have Chinese, they whatever, African,
Yes.
American.
Yes.
I said, you need to go and get back out there recruiting in New York's high schools. And they said, we don't do that. So I said, okay, we'll do it. So I got the board of advisors to the engineering school, which were all the movers and shakers of the Manhattan graduates,
Yes.
who were mostly owners of big engineering firms. We started ACE. Started in New York, then Connecticut, then Newark, New Jersey. And then, as I explained earlier, each time we acquired an office, I started it in another city.
Yes.
And we've given $22 million in scholarships to high school kids so far. And we've
Yes.
graduated almost 100,000 students. We graduate now about 1,000 a year.
Yes.
And they all go to 4-year architecture, engineering, and construction management schools.
Yes.
So it's a really good program. It really helped Manhattan through a recession that took place in 90. And Manhattan College has the largest civil engineering program in New York State.
Mhm.
And I think there's 25 ACE students there right now.
Okay.
So it was the right thing to do.
Okay.
And if you go on the website and you look at the smiling people, or you look at the cover of my book,
Yeah.
those kids standing under the Petronas Towers, we photoshopped that. And those kids are standing on the roof of a building in Chicago. They're not standing. Yep.
Yeah.
So it's been good for Thornton Tomasetti. It's been good for the high school kids.
Yes.
Colleges love it. People who teach are generally lazy. and the university system is set up so that the provost takes care of the faculty, and the faculty does no recruiting. They leave that all to admissions people, and admissions people don't really know what they're doing.
Charlie, thank you so much for carving out time for the show today and your service to our profession with your creativity and innovative design of some of the most prominent structures around the world. You are truly an inspiration for many of us. I hope you enjoyed being a part of this show today. Would you like to share any of your closing thoughts with our listeners today?
No, just I'm proud of what I accomplished. I'm proud of what everybody at Thornton Tomasetti has accomplished, and I think we have raised the bar on what structural engineers can do and are recognized what they can do.
Yeah.
So it's the way I've always worked. And when I walk into an architect like Caesar Pelli, I have a felt tip pen in my hand and I start drawing. I say, what are you trying to achieve? What's your dream? And I start drawing what I think their dream is. And guess what? After one meeting, we have a scheme.
Yeah.
Very few engineers can do that.
Yes. Yes.
It takes a lot of experience, but I also have a very, very strong spatial relations ability to see it. I'm an artist. I paint
Great.
sailboats and lighthouses and geometric forms. And when I make sketches, the architect, they keep them and they frame them. Well, first you have to learn to listen. You have to listen to your client as to what they really think they want to do. And then you have to give them a solution that either solves what they want to do, or you are convincing enough that you tell them that you think that maybe they should do it a little bit different.
Yes.
And then you got to prove it. And so, when I walk into the room and I show them TGE top down, the first reaction from the contractor is, we've never done that, so we can't do it. The first reaction from the architect is, no columns, I love it. And the developer or the owner says, how much am I going to save?
Yes.
And I say 20% on money and 30% on time. And then smart, the wise ass ones, the developers that are really wise guys, they say, so who determines the savings, you or me? And I go, we determine the savings.
Yeah.
And we'll give you how much you're going to save. And we'll tell you how much we're getting paid.
Yes.
And the contractor's not even interested in thinking about what we're saying we're doing. They say, we haven't done it before, so we can't do it. The architects sometimes resent the fact that we're a design builder and they have to work for us. But that's the only way that I can achieve what I'm trying to do. I have to control the construction process.
Yes.
If we leave the construction to somebody else and they send it out to their favorite steel fabricator who doesn't understand the system, we get garbage back.
Yeah.
So, I mean, Richard Tomasetti's mother at a family gathering said, Richard, I forgot, are you an engineer or an architect?
Yeah.
And then most people, if you ask what an engineer does, they say, oh, they drive a train.
Yeah.
Right?
Yeah.
And a janitor is a stationary engineer.
Yeah.
That's a term in New York City. I'm a stationary engineer.
Okay. Yeah. So thank you so much everyone for watching this video. Make sure you like, share and comment your thoughts and questions on this video. Type in any questions that you would like to ask Charlie in the comments below, and make sure to subscribe to this channel to help us grow our structural engineering community. See you all in the next episode.
Great. Okay. Thank you.